Welcome to a journey through the most peaceful corners of our universe, where we'll explore the gentle mysteries of the cosmos that will ease your mind and help you drift into the most restful sleep. Tonight, we're going to float together through the vastness of space, discovering facts that are so wonderfully calming, so beautifully simple, that they'll carry you away from the worries of your day and into a state of pure relaxation. So get comfortable, close your eyes if you'd like, and let's begin this soothing voyage through the stars. Let's start with something truly mesmerizing. Did you know that there's a sound in space, a deep humming that's been going on for billions of years? Now, we often hear that space is silent, and in one way, that's true because sound needs air or some medium to travel through, and space is mostly empty. But there's something even more incredible happening out there. The universe itself is humming. Scientists have discovered that black holes can create sound waves. And there's one particular black hole at the center of the Perseus galaxy cluster that's been singing the same note for over 2 billion years. Imagine that. A note so low, so deep, that it's 1,000,000 billion times lower than anything the human ear could hear. It's the deepest note ever detected in the universe, and it's been playing longer than life has existed on Earth. There's something profoundly peaceful about knowing that somewhere out there, in the darkness, the universe is singing its ancient song, a lullaby that's older than time itself, resonating through the cosmic void in perfect, endless rhythm. And speaking of gentle cosmic rhythms, let's talk about how stars twinkle. When you look up at the night sky and see those stars flickering and dancing, do you know what's really happening? Those stars aren't actually twinkling at all. They're shining with perfectly steady light, constant and unchanging, sending their glow across unimaginable distances. The twinkling you see is just Earth's atmosphere. Layers of air with different temperatures and densities, gently bending and shifting the starlight as it passes through. It's like looking at something through water that's slowly moving. The stars themselves are calm, patient, and eternal. They've been shining steadily for millions or even billions of years, and they'll continue shining long after we're gone. There's something wonderfully reassuring about that steadiness, that patience. While everything in our daily lives feels rushed and chaotic, those distant suns just keep glowing, unchanging, reliable, like lighthouse beacons scattered across an infinite ocean now. Let me tell you about something that might change how you think about yourself and your place in the universe. Every atom in your body, every single particle that makes up who you are, was created inside a star. Not just any star, but a massive one that lived its full life billions of years ago and then exploded in a spectacular supernova, scattering its elements across space. The calcium in your bones, the iron in your blood, the carbon in your cells, the oxygen you're breathing right now. All of it was forged in the heart of an ancient star. You are literally made of stardust. When Carl Sagan said we are all star stuff, he wasn't being poetic. He was stating a beautiful scientific fact. Think about that for a moment. You and the stars are family. You share the same origin, the same building blocks, the same cosmic heritage. That star that created you died so that you could exist, and in doing so, it scattered its gifts across the universe. Some of those gifts eventually came together on a small blue planet, and billions of years later, here you are, a collection of ancient stardust that learned to think and feel and wonder about its origins. You are the universe experiencing itself, a small piece of cosmos that became conscious. And right now, in this moment, you're returning to that cosmic peace, remembering your connection to everything that ever was and ever will be. Let's drift now to the edge of our solar system, to a place so distant and quiet that it takes sunlight over 5 hours to reach it. Out there, beyond Neptune, beyond Pluto, there's a vast region called the Kuiper Belt, and it's filled with billions of icy objects, frozen worlds that have been gently orbiting the sun since the solar system was born 4.5 billion years ago. These are the leftover building blocks of planets, pristine time capsules that never quite came together to form something larger. They just float out there in the cold darkness, patient and undisturbed, following their ancient paths around the sun. Some of them are tiny, just a few kilometers across. Others are hundreds of kilometers wide. Little frozen worlds covered in ice made of water, methane, and ammonia. They're so far from the sun that their surface temperatures hover around -220 degrees Celsius. So cold that time itself seems to move differently there. Nothing changes quickly in the Kuiper Belt. Everything happens in slow motion, measured in millions of years. An impact that might take seconds to happen plays out over decades. A mountain of ice that might melt in days on Earth will stand unchanged for eons out there. It's the most patient place in our solar system, a realm of perfect preservation and infinite calm. And speaking of calm places, these are special locations where the gravitational forces of two large bodies, like the Earth and the Sun, or the Earth and the Moon, perfectly balance out. At these points, a smaller object can essentially park itself and stay there with very little effort, just floating in perfect equilibrium. It's like finding a still point in a river where the currents all cancel out, and you can just rest without being pulled in any direction. We've actually placed telescopes and satellites at some of these Lagrange points because they're such stable, quiet places. The James Webb Space Telescope, one of humanity's most advanced eyes on the universe, sits at a Lagrange point about 1,000,000 miles from Earth, in a spot where it can float peacefully, balanced between the gravitational pulls of the Earth and the Sun, with a perfect view of the cosmos. There's something beautifully symbolic about that, isn't there? In a universe of constant motion and powerful forces, there exist these pockets of perfect balance. These cosmic rest stops where everything finds equilibrium. They remind us that even in the midst of chaos and change, there are always places of stillness if you know where to look. Asterisk. Now let's think about the speed of light for a moment. But not in the way you might expect. We usually think of light as incredibly fast, and it is, traveling at about 300,000 kilometers per second. But here's the beautiful thing. On cosmic scales, light is actually quite slow. When you look at the moon, you're seeing it as it was about a second ago, because that's how long it takes moonlight to reach your eyes. When you look at the sun, you're seeing it as it was 8 minutes ago. The sunlight warming your face right now left the sun 8 minutes in the past. And the stars, oh, the stars are even more remarkable. That bright star you see might be showing you light that left its surface 4 years ago, or 40 years ago, or 400 years ago. When you look at the Andromeda galaxy on a clear night, the faint smudge of light you're seeing began its journey 2.5 million years ago, long before humans existed. In a very real sense, when you look up at the night sky, you're looking back in time. The universe is showing you its history, a visual record of where everything was and how it looked in the distant past. And here's the truly peaceful part. This means that somewhere out there, there's light from Earth that's traveling through space right now, carrying an image of our planet from years or decades ago. Maybe it's light from a sunset that happened when you were a child, still journeying outward, a preserved moment, traveling through the cosmos forever. Every moment of Earth's history is still out there somewhere, encoded in light, spreading outward through the universe in an ever-expanding sphere of memories. Nothing is truly lost. Every sunset, every smile, every peaceful moment is still traveling through space, preserved in light, an eternal record of everything that ever was. Let me tell you now about cosmic voids, because they might be the most relaxing places in the entire universe. The universe isn't evenly distributed, you see. Galaxies tend to cluster together in groups and superclusters, forming vast cosmic webs connected by filaments of dark matter and scattered galaxies. But between these structures, there are enormous empty regions called cosmic voids, and they are almost unimaginably vast and empty. Some of these voids are hundreds of millions of light years across, regions of space so empty that they contain almost nothing at all. Just imagine floating in one of these voids. In every direction you look, for hundreds of millions of light years, there would be almost complete darkness. The nearest galaxy might be so far away that it would appear as just the faintest smudge of light, barely distinguishable from the background. There would be no stars, no planets, no asteroids, just you and the void, and an almost perfect silence. The universe in its most serene state, undisturbed and pristine. These voids make up most of the volume of the universe. All the galaxies, all the stars, all the planets, all the life we know about exist in the relatively small spaces between the voids. Most of the universe is just peaceful, empty space, calm and undisturbed, existing in a state of near-perfect tranquility. There's something deeply reassuring about that, knowing that the universe, in its natural state, prefers peace and emptiness and silence. And while we're talking about peaceful emptiness, let's consider the future of the universe for a moment. Because even though it might seem sad at first, there's actually something quite calming about it. The universe is expanding, and not just expanding, but accelerating in its expansion. Galaxies are moving away from each other faster and faster, driven by something we call dark energy. In the very distant future, trillions of years from now, this expansion will have carried most galaxies so far apart that they'll be beyond each other's cosmic horizon. An observer in some distant galaxy in that far future will look out into space and see almost nothing. Their own galaxy, or perhaps a small cluster of merged galaxies, will be all they can see, surrounded by darkness in every direction. The cosmic microwave background radiation will have stretched and faded into nothingness. The last stars will have burned out. Everything will be cold and dark and still. This is called the heat death of the universe, and while it might sound melancholy, there's actually something quite beautiful about it. After all, the drama of cosmic history, all the explosions and collisions and births and deaths of stars, the universe will finally find its ultimate state of rest. Maximum entropy, perfect equilibrium, absolute peace. Everything will have reached no more change, no more conflict, no more turbulence, just perfect, eternal calm. And knowing that's where everything is heading. That peace is the ultimate destiny of all things. There's something quite soothing about that. It means that no matter what chaos we experience, no matter what disturbances trouble our present moment in the very long run, everything returns to peace. But let's return to the present and talk about something closer to home. Something you can see tonight if you look up. The moon is tidally locked to Earth, which means it always shows us the same face. It takes the moon the same amount of time to rotate once on its axis as it takes to orbit once around Earth, about 27 days. This perfect synchronization happened naturally over millions of years as Earth's gravity gently tugged on the Moon, gradually slowing its rotation until it matched its orbit. The result is that there's a far side of the Moon that we never see from Earth. And it remained a complete mystery until we sent spacecraft to photograph it. For all of human history, until just a few decades ago, half of our closest celestial neighbor was hidden from us. And here's what's beautiful about this. That far side is almost the same as the near side. Same ancient craters, same dusty surface, same gray rocks. There was no hidden mystery, no shocking revelation, just more Moon. Just as peaceful and unchanging as the side we've always known. The Moon has been showing us her face for billions of years, patient and constant, going through her gentle phases, waxing and waning in her eternal cycle. She's been a silent companion to Earth through its entire history, watching over the planet as life evolved from simple cells to everything we see today. She's pulled the tides, lit the night, inspired countless poems and songs, and she's done it all with the same serene face. Never rushing, never changing her pace, just quietly orbiting, month after month, year after year, eon after eon. There's something deeply comforting about that constancy. No matter what changes happen in our lives, no matter how much the world around us transforms, the Moon will still be there, still showing us her familiar face, still following her ancient path. Let's talk now about the slowest things in the universe, because in our fast-paced world, it's deeply relaxing to remember that the cosmos operates on very different timescales. Consider continental drift here on Earth. The continents are constantly moving, but so slowly that you'll never notice it in your lifetime. North America is moving away from Europe at about the same rate your fingernails grow, roughly 2 to 3 centimeters per year. That might not sound like much, and it isn't, not on human timescales. But given enough time, given millions and millions of years, continents cross oceans, mountains rise from flat plains, and entire new worlds are shaped. And in space, things move even more slowly relative to their size. Galaxies are colliding with each other, but these collisions take hundreds of millions of years to complete. The Andromeda Galaxy is currently heading toward our Milky Way, and in about 4 billion years, they'll begin to merge. But calling it a collision is almost misleading because it will be the slowest collision imaginable. Stars are so far apart that even when two galaxies pass through each other, almost no stars actually hit each other. They just slowly, gracefully, over hundreds of millions of years, intermingle and eventually settle into a new configuration. It's less like a car crash and more like two swarms of fireflies slowly drifting through each other on a summer night. Gentle, gradual, patient. And after it's all over, after those hundreds of millions of years have passed, there will be a new galaxy, larger and different, but just as peaceful as the two that merged. The universe knows how to take its time. It's never in a hurry. Everything happens at exactly the pace it needs to happen. No faster, no slower. Just the natural unfolding of cosmic processes that have been going on since the beginning of time. And speaking of the beginning of time, let's think about the cosmic microwave background radiation for a moment. This is the afterglow of the Big Bang itself, the oldest light in the universe, and it's all around us right now. About 380,000 years after the Big Bang, the universe had cooled enough for atoms to form, and for the first time, light could travel freely through space. Before that, the universe was so hot and dense that light couldn't go anywhere. It just bounced around like a person trying to walk through a dense crowd. But once atoms formed, light was free, and it started traveling. And it's been traveling ever since. Over billions of years, that light has stretched and cooled as the universe expanded, shifting from visible light down through infrared and into microwaves. Now it surrounds us as a faint microwave glow coming from every direction, a whisper from the birth of everything. If you could see microwaves with your eyes, the whole sky would glow with this faint, even light, a constant reminder of where we came from. And here's the beautiful thing. This radiation is almost perfectly uniform, almost exactly the same temperature in every direction, just 2.7 degrees above absolute zero. There are tiny variations, tiny ripples that eventually became the galaxies and stars and planets. But mostly, it's just beautifully, perfectly smooth. It's like the universe started with a blank canvas, almost perfectly even and peaceful, and then gently, over billions of years, structure slowly emerged, like a watercolor painting gradually taking shape. That primordial peace is still here, still surrounding us, whispering its ancient message from the moment when time itself began. Now, let me tell you about neutrinos, because they might be the most ghostly, peaceful particles in the universe. Neutrinos are tiny particles, so tiny they're almost nothing at all, and they barely interact with matter. Trillions of neutrinos are passing through your body right now, streaming through you from the sun, and you don't feel a thing. They pass through the entire Earth as if it wasn't even there. They're so weakly interacting that they can travel through light years of solid lead and probably never hit anything. They're like cosmic ghosts, present but untouchable, everywhere but nowhere. constantly streaming through the universe in unimaginable numbers. Most of them were created in the cores of stars, where nuclear fusion produces them as a byproduct. Every second, 65 billion neutrinos from the sun pass through every square centimeter of your body. That's a staggering number, and yet you're completely unaware of it. Right now, as you listen to this, you're being bathed in an invisible shower of solar neutrinos, and they're passing through you at nearly the speed of light, barely noticing you exist. There's something quite peaceful about these ghost particles, going about their business, traveling across the cosmos, connecting everything without disturbing anything. They're produced in the sun, pass through you, continue down through the earth, and emerge on the other side, heading out into space to continue their journey across the galaxy and beyond. They're like cosmic messengers, carrying news from the hearts of stars, traveling in silence, disturbing nothing, just passing through, eternal travelers on an endless journey. Let's turn our attention now to the planet Jupiter, because it's actually Earth's cosmic bodyguard. And there's something quite comforting about having a protector like that. Jupiter is enormous, more than 300 times more massive than Earth. And its gravitational pull is so strong that it acts like a cosmic vacuum cleaner, pulling in asteroids and comets that might otherwise threaten the inner solar system. Over the billions of years that our solar system has existed, Jupiter has taken countless impacts that might have hit Earth instead. Those famous scars on Jupiter's surface, those storms and swirls and spots, they are partly the result of debris impacts, objects that Jupiter captured or crashed into its atmosphere. The most famous example happened in 1994 when comet Shoemaker Levy 9 broke apart and slammed into Jupiter in a series of spectacular impacts. Each impact released as much energy as millions of nuclear bombs, creating dark scars in Jupiter's atmosphere that were visible from Earth. If that comet had hit Earth instead, it would have been catastrophic, possibly civilization ending. But Jupiter, our silent guardian, took the hit instead. It's been doing this for billions of years, quietly protecting the inner planets, making it safer for life to develop on Earth. We owe Jupiter a debt we can never repay, and it asks for nothing in return. Just continues its endless orbit around the sun, spinning once every 10 hours, majestic and powerful, patient and protective, watching over the solar system like a benevolent giant, ensuring that its smaller planetary siblings can exist in relative peace. And while we're talking about protection and peace, let's consider Earth's magnetic field, because it's another invisible guardian that makes life on our planet possible. Deep inside Earth, the molten iron core is constantly churning and flowing, and this motion generates a magnetic field that extends far out into space, creating a protective bubble called the magnetosphere. This magnetic field shields us from the solar wind, a constant stream of charged particles flowing out from the sun at speeds of hundreds of kilometers per second. Without our magnetic field, this solar wind would gradually strip away our atmosphere, just like it did to Mars billions of years ago. But Earth's magnetosphere deflects most of these particles, sending them flowing around our planet like water around a rock in a stream. When some of these particles do make it through near the poles, they interact with our atmosphere and create the auroras, those beautiful dancing lights in the sky, the northern and southern lights. So those auroras are actually visible evidence of our planet's protective shield at work. Earth's magnetic field is constantly there, invisible and unnoticed, quietly doing its job. And it's been doing this for billions of years, creating a safe harbor where life could emerge and evolve, and eventually wonder about its place in the cosmos. We live inside this protective bubble, this gentle magnetic embrace, and we're safe here, sheltered from the harsh environment of space, free to grow and live and dream. Let's drift now to Saturn, that magnificent ringed world that looks like it was designed by an artist who understood beauty and balance. Saturn is probably the most visually stunning planet in our solar system. And those rings are even more remarkable than they first appear. They're made of countless billions of particles of ice and rock, ranging in size from tiny grains smaller than sand to house-sized chunks, all orbiting Saturn in perfect harmony. And here's what's truly mesmerizing. Despite stretching over 280,000 kilometers from edge to edge, making them wider than two Earths placed side by side, those rings are incredibly thin. In most places, they're only about 10 meters thick. Imagine something as wide as the distance from New York to Los Angeles, but only as thick as a 3-story building. They're like a cosmic DVD, a vast flat disk of material that catches the sunlight and shimmers with an ethereal glow. And those rings aren't solid. They're not like a rigid structure. Each particle is following its own individual orbit around Saturn, moving at its own pace, occasionally bumping into its neighbors in gentle collisions that happen in slow motion. The whole system is in perfect gravitational balance, maintained by Saturn's pull and the gentle shepherding influence of some of Saturn's many moons. Those rings have probably been there for hundreds of millions of years, possibly billions, just peacefully orbiting, catching sunlight, creating one of the most beautiful sights in the solar system. When the Voyager spacecraft flew past Saturn in the 1980s and sent back those first detailed images, scientists and ordinary people alike just stared in wonder. Here was beauty on a planetary scale, a reminder that the universe doesn't just follow physical laws. It creates art. Now, let's talk about something that might seem strange at first, but becomes quite soothing. When you think about it, time moves at different speeds depending on where you are and how fast you're moving. Einstein discovered this over a century ago with his theory of relativity, and it's been proven many times since. If you were to spend time near a very massive object, like a black hole, time would pass more slowly for you than for someone far away from that massive object. And if you traveled at very high speeds, close to the speed of light, time would also slow down for you, relative to someone standing still. Astronauts on the International Space Station are moving so fast as they orbit Earth that time passes slightly slower for them than for us on the ground. It's a tiny difference, just a few microseconds over months in space, but it's real and measurable. What this means is that there's no universal now, no single moment that everyone in the universe shares. Right now is different for everyone depending on where they are and how they're moving. It's like the universe is made of countless different flows of time, all running at slightly different speeds, all equally valid, all equally real. And here's the peaceful part. This means that in a very real sense, the past still exists somewhere, and the future already exists somewhere else. All of time, every moment that ever was and ever will be, exists simultaneously in the fabric of space-time. We experience it as a flowing stream, moving from past to future, but that's just our perception, our way of experiencing the universe. In reality, all moments exist together, spread out across the landscape of space-time, like cities on a map. Your childhood is still there, still existing, just in a different location in space-time. Every peaceful moment you've ever experienced still exists, preserved forever in the eternal structure of the universe. Nothing is truly lost. Everything that ever happened is still happening. Somewhere in the infinite tapestry of space-time. Let me tell you now about the most isolated place we know of in the universe. There's a galaxy called UDG 44, an ultra-diffuse galaxy. And it's so incredibly alone that it breaks your heart a little, but in the most peaceful way. This galaxy is about 320 million light-years away from us, but that's not what makes it special. What makes it remarkable is that it's not part of any galaxy cluster, not part of any group, not even close to any other galaxies. It's just out there by itself, drifting through the cosmic void in complete isolation. The nearest other galaxy to UDG 44 is about 6.5 million light-years away. Imagine that. If you lived in that galaxy and looked up at the night sky, you wouldn't see other galaxies scattered around like we can see Andromeda from Earth. you'd just see your own galaxies, stars. And beyond that, darkness. Just empty space stretching in every direction for millions of light years. It would be the loneliest view in the universe, and yet there's something quite peaceful about it too. That galaxy has existed in perfect solitude for billions of years, undisturbed by galactic collisions, untouched by the gravitational influences of neighbors, just quietly going about its existence. Its stars being born and dying, its planets orbiting those stars, all in complete, peaceful isolation. It's a reminder that you can exist perfectly well on your own. That solitude isn't the same as loneliness. That there's a kind of peace that comes from being completely self-contained and undisturbed by external chaos. And speaking of stars being born and dying, let's talk about stellar nurseries, because they're some of the most beautiful places in the universe. When you look at those colorful images from the Hubble Space Telescope or the James Webb Space Telescope, those gorgeous clouds of gas in pink and blue and gold, you're looking at places where new stars are being born. These are nebulae, vast clouds of hydrogen and helium and dust, and they're the maternity wards of the cosmos. Inside these clouds, in the densest parts, gravity slowly pulls material together. Over hundreds of thousands of years, these clumps of gas grow larger and denser, and as they do, they heat up. Eventually, after accumulating enough mass and getting hot enough at their cores. It's a slow, gentle process, nothing sudden or violent about it. Just the patient accumulation of matter and the gradual increase in temperature until finally, light emerges from the darkness. And once a star is born, it doesn't just light up itself. It illuminates the cloud around it, making the nebula glow with beautiful colors. Different elements emit different colors when they're excited by starlight. So you get reds from hydrogen, blues from oxygen, greens from other elements, all mixing together in these cosmic paintings. The Eagle Nebula, the Carina Nebula, the Orion Nebula, these are all stellar nurseries, places where the next generation of stars is slowly coming into being. And they're so beautiful that they almost don't look real. They look like abstract paintings, like someone's artistic interpretation of creation itself. But they are real. They're out there right now, patiently forming new stars, and they'll continue doing so for millions of years to come, creating light from darkness, order from chaos, beauty from simple elements. Now let's consider something wonderfully simple and yet profound. Most of the universe is empty space. Even inside atoms, the building blocks of matter, most of the volume is just emptiness. An atom is mostly empty space with a tiny nucleus at the center and even tinier electrons buzzing around far away from that nucleus. If you could remove all the empty space from all the atoms in your body, if you could compress all your actual matter down with no gaps. You'd be smaller than a grain of sand, almost invisibly small, and yet you feel solid. The chair you're sitting on feels solid. Everything around you feels solid and real. That's because of the electromagnetic forces between atoms, the way electrons repel each other, creating the sensation of solidity even though it's mostly just empty space pushing against other empty space. And this is true of everything. The Earth is mostly empty space. The Sun is mostly empty space. The entire universe is mostly empty space with little specks of matter scattered through it. It's like a vast ocean with occasional drops of water that are more concentrated than the rest. And there's something quite calming about this, knowing that all the things we worry about, all the objects we accumulate, all the physical stuff that seems so solid and important, it's all mostly just emptiness, temporary configurations of force fields and particles, here for a moment and then gone, return to the void from which it briefly emerged. We're all just patterns in the emptiness, waves in the ocean of space. And when we're gone, that emptiness remains, patient and eternal and perfectly at peace. Let me tell you about pulsars now, because they're like the universe's most precise clocks. And there's something deeply satisfying about their perfect regularity. Pulsars are neutron stars, the collapsed core of massive stars that exploded as supernovas. They're incredibly dense, so dense that a teaspoon of neutron star material would weigh about 1 billion tons on Earth, and they're spinning, rotating on their axis incredibly fast, sometimes hundreds of times per second. As they spin, they emit beams of radiation from their magnetic poles. And if those beams happen to point toward Earth during each rotation, we see regular pulses of radio waves, like a cosmic lighthouse sweeping its beam across the ocean. And here's the remarkable thing. These pulses are incredibly regular, more regular than any clock humans have ever built. The most stable pulsars keep time so accurately that they lose less than a second over millions of years. There are better timekeepers than atomic clocks. Scientists have even proposed using pulsars as a kind of cosmic GPS system, a way to navigate through space by measuring the timing of pulsar signals. There's something wonderfully reassuring about these cosmic timekeepers. These lighthouses scattered through the galaxy, spinning with perfect regularity, marking time with absolute precision. In a universe of chaos and change, pulsars are bastions of order, reliable beacons that have been keeping perfect time for millions of years, and will continue doing so for millions more. They're proof that even in the aftermath of stellar death, even in the chaos of a supernova explosion, order and precision can emerge. Something stable and reliable can be created. Let's float now to the edge of the observable universe, to the most distant objects we can see. Looking out into space, We can see galaxies that are so far away, their light has been traveling toward us for over 13 billion years, almost as old as the universe itself. These galaxies appear to us as they were in the early universe, young and small and different from the mature galaxies we see nearby. We're looking back through time, seeing the universe's baby pictures. And here's what's beautiful about this. Everywhere we look, in every direction, we see roughly the same thing. The universe looks pretty much the same in all directions. This is called the cosmological principle. The idea that the universe is homogeneous and isotropic, meaning it's basically the same everywhere and looks the same in all directions. There's no center, no edge, no special place. Wherever you are in the universe, if you look out, you'll see roughly the same thing. Galaxies scattered through space, clusters and voids, the cosmic web stretching as far as you can see. This means Earth isn't special in terms of its location. We're not at the center of anything. We're just on one ordinary planet, orbiting one ordinary star, in one ordinary galaxy, in one ordinary part of the universe. And far from being disappointing, there's something quite comforting about this. It means the universe isn't about us. We're not burdened with being at the center of everything. We're just one small part of an enormous cosmos, free to exist without the weight of cosmic significance. We can just be, just like every other part of the universe. No more important and no less important than anything else. Now, let's think about dark matter for a moment. Because even though we can't see it or touch it, it's mostly what the universe is made of. And there's something mysteriously peaceful about that. Scientists discovered that galaxies rotate in a way that doesn't make sense based on the visible matter alone. The stars on the outer edges of galaxies move too fast. They should fly apart, but they don't, which means there must be extra mass we can't see, holding everything together with its gravity. We call this dark matter, and it makes up about 85% of all the matter in the universe. Everything we can see, all the stars and galaxies and nebulae and planets, all of it is just 15% of the matter that exists. The rest is invisible, detectable only through its gravitational effects. We don't know what dark matter is made of. It's one of the biggest mysteries in science. But whatever it is, it's everywhere, surrounding every galaxy, threading through the cosmos, holding structures together with its invisible gravitational embrace. We're swimming in it right now. Dark matter is passing through you, through the Earth, barely interacting with ordinary matter at all. It's like a ghost universe overlapping with ours, present but unseen, essential but mysterious. And there's something quite peaceful about knowing that most of reality is hidden from us, that the universe keeps its secrets, that there's so much we don't know and may never know. It's a reminder to be humble, to accept that understanding has limits, that mystery is okay, that not everything needs to be explained or understood. The universe is under no obligation to make sense to us, and dark matter is a perfect example of that. A reminder that reality is stranger and more wonderful than we can imagine. Let's turn our attention now to something closer and more familiar. The sun, because even though we see it every day, it's easy to forget just how remarkable and peaceful it really is. The sun is a middle-aged star, about 4.5 billion years old. And it's got about another 5 billion years to go before it dies. It's been shining steadily for all that time, providing light and heat to Earth, making life possible. And it does this through nuclear fusion, converting hydrogen into helium in its core, a process that releases enormous amounts of energy. Every second, the sun converts about 600 million tons of hydrogen into helium, and in doing so, releases as much energy as billions of nuclear bombs. And yet, despite this unimaginable violence happening in its core, the sun appears to us as a calm, steady presence in the sky. That's because it's in perfect balance. The outward pressure from all that fusion energy is exactly balanced by the inward pull of gravity. It's been in this state of equilibrium for billions of years and will remain there for billions more. This is called hydrostatic equilibrium, and it's why stars are so stable. They find this perfect balance point and then just stay there, shining steadily, neither collapsing nor exploding, just burning their fuel at a steady rate that can last for billions of years. The sun rises and sets with perfect regularity, day after day, year after year, century after century. Civilizations have risen and fallen. Species have evolved and gone extinct. Continents have drifted and collided. And through it all, the sun just keeps shining, steady and reliable, our cosmic hearth, warming our little planet, making everything possible. And speaking of making things possible, let's talk about the habitable zone, that special region around a star where conditions are just right for liquid water to exist on a planet's surface. It's sometimes called the Goldilocks zone, not too hot and not too cold, but just right. Earth sits comfortably in the sun's habitable zone, and that's why we have oceans of liquid water. Why life was able to emerge and evolve and eventually become complex enough to wonder about the stars. But here's the beautiful thing. We now know that most stars have planets, and many of those stars have planets in their habitable zones. The Kepler Space Telescope and other planet-hunting missions have discovered thousands of exoplanets. And statistical analysis suggests that there are probably more planets in the Milky Way than there are stars. Billions of planets. And a significant percentage of those planets are in their star's habitable zone. This means there are potentially billions of worlds in our galaxy alone where the conditions might be right for life. We don't know if life actually exists on any of those worlds, but the possibility is there, and that's quite wonderful. It means Earth probably isn't unique. Life might be common in the universe, or at least not impossibly rare. Right now, as you listen to this, there might be countless other worlds scattered across the galaxy where water flows, where atmospheres swirl with clouds, where sunlight warms landscapes, where conditions are suitable for biology. Some of those worlds might have simple microbes. Others might have complex ecosystems. A few might even have intelligent beings looking up at their own night skies, wondering if they're alone, just like we do. We're probably not alone in the universe, and even if we never meet our cosmic neighbors, even if the distances are too vast for contact, there's something quite comforting about knowing they're probably out there, living their lives on distant worlds under alien skies, wondering the same questions we wonder. Let me tell you now about the cosmic web, the large-scale structure of the universe, because when you zoom out far enough, the universe looks like a work of art. Galaxies aren't distributed randomly through space. They're organized into a vast web-like structure. Galaxies cluster together along filaments, long strands of dark matter, and galaxies that stretch across hundreds of millions of light years. These filaments connect clusters of galaxies, forming a network that looks remarkably like a spider's web or the neural network of a brain. Between the filaments are those cosmic voids we talked about earlier, vast empty regions where almost nothing exists. This cosmic web is the largest scale structure in the universe, and it formed naturally through gravity acting on tiny variations in density that existed in the early universe. Over billions of years, denser regions pulled in more matter, creating the filaments and clusters, while less dense regions became voids. And here's what's mesmerizing. This structure is fractal-like, meaning it looks similar at different scales. A cluster of galaxies looks like a miniature version of a supercluster, which looks like a miniature version of the cosmic web. It's patterns within patterns, order emerging naturally from chaos through the simple action of gravity over time. And this web is constantly evolving, slowly changing as galaxies move and merge and new ones form. But the overall structure remains stable, a vast cosmic architecture that will persist for billions of years. When you see computer simulations of the cosmic web, with its delicate filaments glowing with galaxies and vast dark voids between them, it takes your breath away. It's beautiful in a way that seems almost intentional, as if the universe wanted to create art and chose to paint with galaxies and dark matter on a canvas, billions of light years across. Now, let's think about cosmic recycling. because the universe wastes nothing, and there's something quite satisfying about that. When a star dies, it doesn't just disappear. If it's a massive star, it explodes as a supernova, scattering its elements across space. Those elements, forged in the star's core and in the violence of the explosion, eventually become part of new nebulae, which eventually form new stars and planets. The atoms that made up one star can become part of thousands of other stars over billions of years. Your body contains atoms that were once part of other stars, other planets, maybe even other living things on Earth. The iron in your blood might have been forged in a supernova billions of years ago, then spent time in various stars and planets before eventually becoming part of you. And when you die, those atoms will continue on, becoming part of other things, other people, other forms of life, eventually, perhaps, returning to space and becoming part of new stars. Nothing is ever truly created or destroyed in the universe, just transformed, recycled, rearranged into new configurations. This has been going on for nearly 14 billion years, and it will continue for billions or trillions more. Every atom in existence has its own history, its own journey through the cosmos, and you're just a temporary chapter in that atom story. There's something beautiful about being part of this cosmic cycle, knowing that you're connected to everything that came before and everything that will come after, that you're made of stardust and will return to stardust, that you're a temporary eddy in the eternal flow of matter and energy through the universe. Let's drift back to our solar system now and visit Neptune, the most distant planet, a world of beautiful, deep blue color and incredible winds. Neptune is about 30 times farther from the Sun than Earth is, so far away that sunlight takes over 4 hours to reach it. At that distance, the Sun looks like just a very bright star in the sky, providing almost no warmth. Neptune's surface temperature is about -200 degrees Celsius, cold enough to freeze almost anything. And yet, despite receiving so little energy from the Sun, Neptune has the fastest winds in the solar system, screaming through its atmosphere at speeds over 2,000 kilometers per hour, faster than the speed of sound on Earth. Scientists still don't fully understand where these winds get their energy. Neptune must have some internal heat source driving this incredible atmospheric activity. The planet is a beautiful azure blue because of methane in its atmosphere, which absorbs red light and reflects blue. It's the same reason Earth's oceans look blue, but the effect is even more pronounced on Neptune, this distant, frigid world, so far from the Sun that it takes over 160 Earth years to complete one orbit, is still dynamic and active, still interesting and complex. It reminds us that even in the cold outer reaches of the solar system, even far from the Sun's warmth, there's still beauty and activity and mystery. Neptune was discovered in 1846 through mathematical predictions before it was ever seen through a telescope. Astronomers noticed that Uranus wasn't following its predicted orbit exactly, suggesting another planet's gravity was tugging on it. They calculated where that planet should be, pointed their telescopes at that spot, and there it was. Neptune, right where the math said it should be. It was a triumph of human understanding, proof that we can comprehend the cosmos through reason, and mathematics that the universe follows laws we can discover and understand. Let's journey now to one of the most peaceful phenomena in all of space. Something so gentle and beautiful that it's been captivating humans for thousands of years. I'm talking about meteor showers, those nights when the sky seems to rain light, when dozens or even hundreds of shooting stars streak across the darkness in a celestial display that never fails to inspire wonder. But here's what makes meteor showers even more beautiful when you understand what's really happening. Those shooting stars aren't stars at all. They're tiny pieces of dust and rock. Most of them no bigger than a grain of sand left behind by comets as they orbit the sun. When Earth's orbit crosses through these trails of debris, those particles enter our atmosphere at incredible speeds, around 70 kilometers per second, and the friction with air molecules causes them to heat up and glow, creating those brilliant streaks of light we see. Each meteor you see is a tiny piece of an ancient comet, material that's been drifting through space for millions of years, finally meeting its end in a brief moment of beauty. And the wonderful thing is that meteor showers are predictable. The Perseids happen every August, the Geminids every December, because Earth passes through the same debris field at the same time every year. You can set your calendar by them. It's like the universe sending us regular gifts, reminding us to look up, to remember that we're part of something vast and ancient and beautiful. On a clear night, during a good meteor shower, you might see 1 or 2 meteors every minute, sometimes more during the peak. Each one is a tiny farewell, a speck of cosmic dust saying goodbye in the most spectacular way possible, burning up in our atmosphere, giving us light in its final moment. There's something poetic about that, something that reminds us that even endings can be beautiful, that every conclusion can be a moment of brightness. And speaking of comets, let's talk about these wanderers of the solar system, because they're some of the most ancient and pristine objects we know. Comets are like frozen time capsules from the birth of the solar system, chunks of ice and rock and dust that have been orbiting the sun for 4.5 billion years, mostly unchanged. They spend most of their time in the cold outer reaches of the solar system, in regions like the Kuiper Belt or the even more distant Oort cloud, where they can remain frozen and dormant for millions of years. But occasionally, gravitational interactions will nudge a comet's orbit, sending it falling toward the inner solar system. As it gets closer to the sun and warms up, the ice begins to vaporize, creating that characteristic glowing head and long tail that makes comets so spectacular. The tail always points away from the sun because it's pushed by the solar wind and radiation pressure. So a comet's tail actually leads the way when it's heading back out to the cold outer solar system. Ancient peoples saw comets as omens, harbingers of change. And while we now know they're just icy visitors from the outer solar system, there's still something magical about seeing one in the night sky. They're reminders that the solar system is full of travelers, objects on long elliptical orbits that take them from the frozen depths of space to brief visits near the sun before returning to the cold darkness for centuries or millennia. Some comets take thousands of years to complete one orbit. Imagine that, an object that visited the inner solar system when the pyramids were being built, swung back out into the darkness and is only now returning. Having spent all of human civilization on its long journey through space, let me tell you now about the overview effect, because even though it's something experienced by astronauts, understanding it can bring a kind of peace to all of us. The overview effect is what happens when astronauts look back at Earth from space and see it as a whole. A small blue marble floating in the darkness, with no visible borders, no divisions, just one beautiful, fragile world. Astronauts consistently report that this view fundamentally changes their perspective on life and humanity. They see how thin our atmosphere is, just a delicate blue shell protecting all life on Earth. They see how interconnected everything is, how weather systems span continents, how oceans connect distant lands, how artificial the divisions between nations seem when viewed from space. They feel a profound sense of unity with all humans and indeed all life on Earth, recognizing that we're all passengers on the same small spacecraft traveling through the cosmos together. The astronaut Edgar Mitchell described it as an explosion of awareness, a sense of universal connectedness. The Russian cosmonaut Yuri Gagarin, the first human in space, said that looking at Earth from space made him realize that the Earth is too small for conflict. And even though most of us will never go to space, we can still benefit from this perspective. We can imagine that view, that sense of our planet as a single, unified system, a rare oasis of life in a vast and mostly empty universe. All our conflicts, all our divisions, all the things that seem so important and urgent in our daily lives. They shrink when viewed from that cosmic perspective. What matters is that we're here, alive, on this beautiful world, sharing this moment in cosmic time. Let's think now about the music of the cosmos. Because the universe is full of rhythms and harmonies that, while we can't hear them directly, are no less real or beautiful. We've already talked about that black hole humming its deep note, but there's more cosmic music out there. Planets can create radio emissions as their magnetospheres interact with solar wind. And scientists have converted these emissions into audible sound, creating eerie, haunting music that each planet produces. Jupiter roars and crackles. Saturn produces what sounds like a choir of ethereal voices. Earth itself sings, producing electromagnetic whistles and chirps. Pulsars tick like cosmic metronomes, some of them spinning so fast they create tones. The sun has acoustic oscillations, vibrations that pass through it, making it ring like a bell, though at frequencies too low for us to hear. When gravitational waves pass through space, created by colliding black holes or neutron stars, they literally make space-time vibrate. And scientists have converted these vibrations into sound, creating what they call the sound of black holes colliding. A chirp that rises in pitch and volume as the objects spiral together and merge. The universe is constantly making music, a cosmic symphony that's been playing since the beginning of time. We've only recently developed the technology to listen to it, to convert these various cosmic phenomena into sounds we can hear. But it's always been there. This background music of the cosmos, rhythms and melodies created by the fundamental forces of nature. And there's something quite wonderful about that. Knowing that the universe isn't just a visual spectacle, but a musical one, too. That creation is constantly singing if we have the ears to hear it. Now, let's float out to the heliopause, the boundary, where the sun's influence ends and interstellar space begins. This is where the solar wind, that constant stream of charged particles flowing out from the sun, finally slows down and stops as it meets the interstellar medium, the thin gas and dust that fills the space between stars. The heliopause is about 18 billion kilometers from the sun, so far away that light takes almost 17 hours to travel from the sun to this boundary. Only 5 human-made objects have ever crossed this boundary into interstellar space: Voyager 1, Voyager 2, and potentially Pioneer 10, Pioneer 11, and New Horizons will cross it in the future. Voyager 1 crossed the heliopause in 2012, becoming the first human-made object to enter interstellar space. And it's still out there, still sending back data, still traveling away from the sun at about 17 kilometers per second. Eventually, its power will run out, probably sometime in the 2020s, and it will go silent, but it will keep traveling, coasting through interstellar space for millions of years. In about 40,000 years, it'll pass within about 1.5 light years of a star called Gliese 445. It's carrying a golden record, a disk with sounds and images from Earth, a message in a bottle cast into the cosmic ocean. The chances of it ever being found are infinitesimally small, but it's out there, a testament to humanity's existence, proof that we were here, that we wondered about the stars, that we reached out into the cosmos with curiosity and hope. And there's something quite moving about that, about these tiny spacecraft carrying humanity's greetings into the eternal darkness, traveling long after the people who built them are gone, long after our entire civilization might be forgotten. They're our message to the future, to the universe, saying, we existed, we explored, we dreamed. Let's return closer to home now and think about the moon again, but this time about how it's slowly drifting away from us. The moon is gradually moving away from Earth at a rate of about 3.8 centimeters per year. This is happening because of tidal forces. The moon's gravity pulls on Earth's oceans, creating tides, and those tides create friction, which gradually slows Earth's rotation. To conserve angular momentum in the Earth's moon system, as Earth's rotation slows, the moon must move farther away. This has been going on since the moon formed about 4.5 billion years ago. Back then, the moon was much closer, maybe just 15 or 20,000 kilometers away, compared to the current 384,000 kilometers. Back then, the moon would have looked huge in the sky, maybe 10 or 15 times larger than it does now. And Earth's day was much shorter, maybe just 5 or 6 hours long. Over billions of years, the moon has slowly spiraled outward, and Earth's rotation has gradually slowed, until we've reached the current state where a day is 24 hours and the moon is its current distance. And this process is still continuing. In the distant future, billions of years from now, Earth's day will be even longer, and the moon will be even farther away, appearing smaller in the sky. Eventually, Earth and the moon will become tidally locked to each other, meaning Earth will always show the same face to the moon, just as the moon already shows the same face to Earth. One side of Earth will always see the moon, and the other side will never see it. But this won't happen for billions of years, so there's no need to worry. For now, and for all a foreseeable human future, the moon will continue to grace our night sky, slowly drifting away, but still close enough to inspire us to light our nights, to pull our tides, to be the beautiful companion it's always been. Let me tell you about something called cosmic perspective, a way of thinking about time that can be quite calming. We tend to think of human history as long, and in human terms, it is. Civilization has existed for maybe 10,000 years. Humans as a species have been around for a few 100,000 years. But on cosmic timescales, we're incredibly recent. If you compress the entire history of the universe into one calendar year, with the Big Bang happening at the first second of January 1st, Earth wouldn't form until early September. The first simple life on Earth wouldn't appear until late September. Complex life wouldn't emerge until mid-December. Dinosaurs wouldn't appear until December 26th. They'd go extinct on December 30th. All of human history, from the first humans to the present day, would happen in the last few minutes before midnight on December 31st. Everything we know, all of recorded history, all of human civilization, would fit into the last few seconds of the year. The Roman Empire, the Renaissance, the Industrial Revolution, the Space Age, all of it in the final tick of the cosmic clock. This isn't meant to make our existence seem insignificant. Rather, it's meant to show how precious and remarkable it is that we exist at all. That the universe has brought forth consciousness and curiosity and wonder. We're the universe's way of knowing itself, made possible by billions of years of cosmic evolution. And that makes us incredibly special, even if we're cosmically brief. And let's think about heat death one more time, but from a different angle, because there's a strange comfort in knowing the ultimate fate of everything. Eventually, in the unimaginably distant future. After all, the stars have burned out. After all, the black holes have evaporated through Hawking radiation. After every process that can happen has happened, the universe will reach a state of maximum entropy. This is called heat death. Though it's not really about heat. It's about equilibrium, about everything reaching the same temperature, the same energy level, about no more differences existing anywhere that could drive any kind of change or process. At this point, nothing will happen anymore. No stars will shine because there's no fuel left to burn. No life will exist because there's no energy gradient to power metabolism. The universe will just be a vast, cold, dark, perfectly uniform void at a temperature just barely above absolute zero. And it will stay that way forever, unchanging, perfectly still, perfectly at peace. It's the ultimate rest after the long drama of cosmic history. Some people find this depressing, the idea that everything ends in cold darkness. But there's another way to look at it. Every moment of beauty that ever existed, every star that ever shone, every life that ever lived, every thought that was ever thought, all of it will have happened, all of it will have existed, and nothing can take that away. The fact that it ends doesn't diminish its value. If anything, the temporary nature of everything makes each moment more precious, more worth appreciating. And between now and then, there are trillions of years of cosmic activity left. Trillions of years for stars to shine and worlds to turn. And who knows what forms of life and consciousness to emerge and experience the universe. We're here right now in the golden age of stars, when the universe is full of light and possibility, and that's a gift. Let's talk now about something called panspermia, the idea that life might travel between worlds. We don't know how life began on Earth. It's one of science's great mysteries. But one possibility is that life didn't originate here at all. Maybe it started somewhere else and was transported to Earth, perhaps on a meteorite or comet. We know that rocks can be blasted off one planet by asteroid impacts and eventually land on another planet. We've found meteorites on Earth that came from Mars. If life existed on Mars billions of years ago, when it was warmer and wetter, maybe Martian microbes hitched a ride on these rocks and eventually seeded life on Earth. Or maybe life's origin was even more distant, from outside our solar system entirely, preserved in the frozen interior of a comet that traveled for millions of years through space before delivering its precious cargo to our young planet. We may never know for certain, but it's a beautiful thought, isn't it? The idea that life is a cosmic wanderer spreading from world to world, that we might be related to life on other planets, that all life in the universe might share a common ancestor that lived on some world billions of years ago. It would mean we're not just citizens of Earth or even the solar system, but truly cosmic beings, children of the universe itself, scattered among the stars, connected by invisible threads of biology and chemistry that stretch across light years and eons as we approach the end of our journey together. Let's think about one final beautiful truth about the universe. Despite its vast size, despite its age, despite the enormous energies and forces at play, the cosmos operates according to rules we can understand. The laws of physics are the same everywhere. Gravity works the same way on Earth as it does in the most distant galaxy. Light behaves consistently whether it's generated in our sun or in a star 13 billion light-years away. This fundamental comprehensibility of the universe is perhaps the most remarkable thing about it. We're able to understand the cosmos because we're part of it, made of the same stuff, following the same rules. Our brains, products of evolution on this small planet, are somehow capable of grasping the nature of black holes and quantum mechanics and the curvature of space-time. The universe is knowable, and that's extraordinary. It didn't have to be that way. we could have been trapped in a fundamentally incomprehensible cosmos where nothing made sense and no pattern ever emerged. But instead, we find ourselves in a universe that follows elegant mathematical laws, where patterns exist at every scale, where understanding is possible, even if it's difficult. And that suggests something profound, that consciousness and comprehension are somehow fundamental to the nature of reality, that the universe wants to be known, that our existence as observers and questioners and wanderers is somehow part of the cosmic plan. If such a thing exists, so as you drift toward sleep now, as your consciousness begins to blur and your thoughts slow down, remember that you're cradled in the arms of a vast, ancient, and ultimately peaceful cosmos. You're floating on a small world that's floating through space. And that world is part of a solar system that's moving through a galaxy. And that galaxy is part of a cosmic web stretching across billions of light years. You're connected to all of it, made of atoms that were forged in ancient stars, breathing air that's been recycled through countless living things, thinking thoughts generated by a brain that's the product of 4 billion years of evolution. You're a temporary pattern in a flow of matter and energy through the universe, a brief moment of complexity and consciousness in the long story of existence. And when you sleep, you return a little bit to that cosmic peace, that state of deep rest where boundaries dissolve and you're just part of the universe again. Not separate, not struggling, just being. Sleep is a little preview of the ultimate peace that awaits everything. A nightly rehearsal for the eternal rest at the end of time. But for now, you're here, alive, aware, experiencing this beautiful universe in all its wonder and complexity and mystery. The stars are shining above you right now, even if you can't see them, even if it's daytime or cloudy where you are. They're always there, always shining, sending their ancient light across the light years, patient and eternal and beautiful. The moon is following its ancient path, pulling the tides, marking time as it has for billions of years. Galaxies are slowly spinning in their graceful spirals. Nebulae are birthing new stars. Black holes are humming their deep cosmic notes. Neutrinos are streaming through everything. Dark matter is holding it all together with invisible hands. The universe is going about its business, following its laws, unfolding its story. And you're part of that story, a character in the greatest narrative ever told, the story of existence itself. And now it's time to rest, to let go, to drift into that peaceful darkness where dreams live, where consciousness softens and dissolves, where you can float free from the concerns of the day and just be, just exist, just rest in the eternal now. The universe will still be here when you wake. The stars will still shine. The cosmos will continue its ancient dance. But for now, it's time to sleep, to surrender to the gentle pull of rest, to let the peaceful truths of the cosmos carry you away into the deepest, most restful sleep you've had in a long time. Let the universe hold you. Let the cosmic rhythms rock you gently. Let the knowledge that you're made of stardust comfort you. Let the vastness of space remind you that your worries are small and temporary. Let the age of the cosmos help you. Understand that you have time, that everything happens at its own pace, that there's no rush, no urgency, just the eternal now, stretching out peacefully in all directions. You're safe here, on this small world, protected by magnetic fields and atmosphere and the vast distance between the stars. You're part of something beautiful and ancient and ongoing. You belong here, you're home. And now, finally, gratefully, peacefully, you can rest. Close your eyes, breathe slowly. Feel yourself sinking into comfort, into softness, into that gentle darkness that leads to dreams and restoration and peace. The cosmos whispers its lullaby, the same song it's been singing since the beginning of time, and you're listening, and you're part of it, and everything is exactly as it should be. Sleep now, dear traveler. Sleep deeply, sleep peacefully. The universe is watching over you, and all is well, all is well. All is perfectly, beautifully, eternally well. Good night.